Yeah, I'll react to that, sure. Look at that beard.
Did you know?
Okay, Voyager 2, Beyond the Heliosphere. Why is it? Hello. I'm going to be up in my little top right corner up here. Spacecraft. Let's go. Original link to the video, top of the description. My name is Connor. I like to learn things and watch stuff on YouTube. Come join us. Hit all the buttons. Original link to the video, top of the description, right below that, link to the Discord. Click on it. Send it right over there. If you do not get assigned a role right away, don't worry. I will check every day or so and promote you. Let's go.
Did you know that 2 out of every 3 guys is going to experience some form of male pattern baldness by the time they're 35? Yeah, I did. For me, it was 25. I wish keeps have been around when I was younger because advancements in science meant that there are now treatments that can combat the symptoms of hair loss and help you keep the hair that you have. It's too late for me. My hair is not coming back, but you don't have to be like me. You can stop your hair loss early thanks to Keeps. Keeps offers generic versions of the only 2 FDA-approved drugs for treating hair loss. So, you might have tried them before, but never at a price this low. That's right, if you were thinking, oh, Simon, this is medicine, it's gonna be expensive, you couldn't be more wrong. Keeps starts at just $10 a month. How does it work? Well, for one thing, there's no need to visit a doctor's office. Just schedule a quick online consult, and a bit later, a discreet package will arrive at your door.
If you guys do this, make sure to use
your own home. Fantastic.
Their link in the description.
If you're noticing that you're losing your hair,
it helps the ad
not gonna fix itself. Do something about it for a limited time.
Push the people towards there, and so they give him more money.
Or click the link in the description below to receive 50% off your first order.
Right.
And now today's video.
Let's go. If you aren't ready to learn, there's the door. FaceTime, phones away.
Voyager 2, the groundbreaking, or should I say, atmosphere-breaking flyby spacecraft. First to many historic achievements for humanity, second to some other firsts. First to achieve other firsts a second time, second to achieve some seconds a first time. 1 spacecraft, 2 missions, half a dozen planets, billions of kilometers, and endless space. Confused yet? Yes. Well, prepare to have your mind truly blown with the story of Voyager 2. Destined to soar endlessly in open space, fated to lose contact with humanity soon. A story whose scope transcends the limits of the solar system and extends far beyond where humanity has ever traveled before. These are scales of time and measurement so vast it's difficult to comprehend through our earthly perspective. This truly is, perhaps, the most mega of mega projects. So suit up, start the countdown, and prepare to launch into a universe of knowledge. Today we're looking at the Voyager 2 spacecraft and its mission around and out of the solar system.
Let's do it.
Voyager 2, to a layman's eye, resembles a kind of weird space shovel if you sort of squinted it hard enough. Aesthetically, the main part of the craft, the blade of the shovel, consists of the 3.6 meter diameter antenna that sends data back to Earth. The antenna is mounted on a decahedral bus, only 47 centimeters, that's 18.5 inches tall, and 1.78 meters, or 5.8 feet wide, which houses much of the craft's electronics. The handle of
Sorry, continue.
The handle of the space shovel measures 13 meters, 42.6 feet long, and holds the magnetometers used to measure the strength and direction of magnetic fields. From the bus, many different booms jut out, containing different instruments and mechanisms. A 2.5 meter, 8.2 foot boom contains a good majority of the scientific instruments.
Sorry, so it's cool how you can have a lot of these like jutting out strange antennae and stuff that you would think would get snap like a twig in any kind of resistances in air on Earth, but because it's a vacuum in space, there's not really any force on these things.
The separate boom that juts down and away from the scientific instruments holds the craft's radioisotope thermoelectric generators, or RTGs, Voyager 2's power source. Finally, 2 whip antennas, both 10 meters or 32.8 feet long, extend out and are used to measure radio emissions from plasma resonances near and lightning on the planets the craft would encounter. Altogether, the craft weighs about 721.9 kilograms, or about 1,600 pounds, on Earth, at least. In space, it doesn't. Given the length of its mission and the distance it would travel away from Earth, Voyager 2 was equipped with several thousand sets of pre-coded instructions that it could execute autonomously. These instructions included error detection and correction routines that would enable the craft to detect and avoid or fix problems before operators back on Earth were even aware of them. This would allow the spacecraft to operate for days, even weeks at a time, with no direct control from humans on Earth. The spacecraft, though, was made during a time when technology was still in its infancy compared to today. To give an example, our modern-day smartphones have over 200,000 times more memory than is contained in Voyager 2. Nonetheless, this spacecraft would collect and send back loads of data, much of which has shaped the modern perception of our neighbors around the sun. Saturday, August the 20th, 1977, United States. A gallon of gas cost 65 cents. A new house, just under $50,000. Fans around the world were mourning the death of Elvis Presley just 4 days prior. Just a month before the Grateful Dead released their 9th studio album, Terrapin Station, and James Bond had sauntered across the silver screen yet again in The Spy Who Loved Me. Meanwhile, at the Kennedy Space Center in Cape Canaveral, Florida, the unmanned spacecraft called Voyager 2 was leaving the surface of the Earth. Though dubbed the second of the duo, Voyager 2 actually took off 2 weeks and 2 days ahead of its sister craft, Voyager 1, which is confusing. The reason for the inverse names and launch dates is credited to the craft's mission timing. Though Voyager 1 launched second, it was put on a trajectory to complete its flybys of Jupiter and Saturn first, hence why it was awarded the Premier moniker, and its brother craft, first to space but destined to play catch-up from then on, the secondary title. To add more depth to the story, the Voyager spacecrafts were originally called by different names, Mariner 11 and 12. Their designs were based heavily off the previous Mariner crafts, but just 5 months before the then Mariner spacecraft's launch, NASA Administrator James C. Fletcher announced the name change. Voyager 1 and 2 represented what was left of NASA's original plan of a grand tour through the solar system, a plan that would have 4 advanced spacecraft explore the outer planets. NASA scrapped the idea after expected costs rose above $1 billion. Instead, NASA scientists proposed an alternative to launch 2 crafts that could observe Jupiter and Saturn in more detail than Pioneer 10 and 11, the predecessors. When Voyager 2 finally launched, mission planners had modified its path to include exploration of Uranus and Neptune as well. This trajectory made using gravity assist maneuvers after flybys of Jupiter and Saturn and was only possible because of the unique alignment of the planets. Such an alignment
that is just so cool and awesome how they can do that. Oh, we'll just use these 2 planets, we'll slingshot them around here, and that'll get us over there. Okay.
Every 176 years. That means NASA won't be able to take advantage of such an alignment again until the year 2153. After its launch in August 1977, Voyager 2 took nearly 1 year and 8 months to reach Jupiter and her moons. Though the images it sent back were following those already sent from Voyager 1, Voyager 2's image came at a much closer range. Now, close in terms of space travel does not equate with close in Earth terms. The photos of Callisto, Ganymede, Europa, Io, Amalthea were all taken at the closest range at a distance of 205,720 kilometers, or about 120.
That's closer than the Earth is to the moon, right?
27,000 miles. To put that in perspective, that's just over 16 times the diameter of Earth. Voyager 2's close brush with Jupiter's moons was from 16 Earth distances away. The closest our intrepid unmanned Voyager got to Jupiter was 645,000 kilometers, or 400,000 miles, or 50.5 Earths. Though to be fair, nearly 11 Earths could fit across the diameter of Jupiter, so the giant planet does take some distance to truly appreciate. Some of what Voyager 2 observed from its distance were atmospheric changes, a drift and changes in the shape and color of the Great Red Spot, and a 3-mile resolution mapping of 80% of Ganymede and Callisto's surface. 2 hours after its closest encounter with Jupiter, an encounter so far away by an object so small that if there is
So the great big spot on Jupiter like 400 years ago wasn't there because supposedly it's like a hurricane type storm on Jupiter that's been lasting that long?
Intelligent life on Jupiter or anywhere, they probably wouldn't have noticed. Then Voyager 2 corrected its course and made its silent, speedy way towards Saturn. It took Voyager 2 another 2 years and 4 months from its encounter with Jupiter to reach the ringed gas giant. Its encounter with Saturn started on August 22nd, 1981, 4 years and 2 days after it left Mother Earth. A baby born at the same time would by then be able to catch a bounced ball most of the time, use scissors, and name some colors and numbers. The 4-year-old Voyager 2 had already taken over 17,000 new pictures, mapped out Jovian moon surfaces, and completed a 10-hour volcano watch on Europa and Io. It's fair to say, Voyager 2 would be a fairly high-functioning child. Voyager 2, still playing catch-up to its twin, sent back much of the same photos of Saturn as had Voyager 1, though it did get around 23,000 kilometers, or just over 14,000 miles closer. Its closest brush came at a distance of 101,000 kilometers, that's 63,000 miles. That's enough distance to travel around the Earth's equator 2.5 times, or to fit 15.5 Amazon rivers in. Voyager 2 transmitted back pictures and data of Saturn's rings and moons, confirming much of what Voyager 1 had sent back earlier.
I wonder what caused, why is Saturn the only planet with rings? I mean, there are other gas planets like Jupiter, anyways.
However, Voyager 2 helped scientists to conclude that Saturn's A-ring was probably only 300 meters or 980 feet thick, a surprisingly thin measurement for something encircling such a large planet, 4.5 times the diameter of Earth big, to be exact. Voyager 2 also photographed several of Saturn's 82 moons: Hyperion, Enceladus, Tethys, Phoebe, Helen, Telesto, and Calypso. The spacecraft even passed through the plane of Saturn's rings at the blistering pace of 13 kilometers or 8 miles a second. This proved fast enough to vaporize the micron-sized dust grains in Saturn's ring of floating debris and create clouds of puff plasma, which caused the spacecraft to fire its attitude control jets to stabilize its path. Voyager 2's successful flyby and documentations of Jupiter and Saturn meant it had fulfilled its primary objectives. However, this wonky, shovel-looking contraption floating through space was far from done with its work. A prime factor setting Voyager 2 apart from its younger, elder sibling was the latter part of its mission. After flying by Jupiter and Saturn, Voyager 1 corrected its course and made its way to exit the solar system. Voyager 2, however, corrected its course with a different name: the outer planets. First stop, Uranus. The journey from its encounter with Saturn to its first contact with Uranus would take Voyager 2 nearly 4 years and 2 weeks to complete, doubling its mission time as it stood then. Voyager 2's flight path, both by Jupiter and Uranus, was optimized to make flybys of Uranus and Neptune possible in that order. On November 4th, 1985, Voyager 2 began long-range observations.
Such a child.
Neptune possible in that order. On November 4th, 1985, Voyager 2 began long-range observations of Uranus, 3 months and 20...
I'm a child laughing at Uranus jokes. Sorry, let's go. I have it out of my system.
And long-range observations of Uranus. 3 months and 20 days later, on January the 24th, 1986, Voyager 2 made its closest contact with Uranus at a distance of 81,500 kilometers or 50,640 miles, enough to fit over 20 Mississippi rivers in, by the way. At this distance from Earth, the information sent from the spacecraft's instruments took 2.5 hours to reach the Earth. By the time the first close images of Uranus reached Earth, Voyager 2 was nearly...
How'd you get those pictures? Those were in private. All right, sorry.
halfway done with its close observations of the planet. Scientists obtained a wealth of knowledge about Uranus from this flyby. They discovered 10 new moons and 2 new rings, 724 km per hour or 450 mile per hour winds, and evidence of a boiling ocean of water nearly 800 kilometers, just under 500 miles, under Uranus's top cloud surface. Voyager 2's path allowed it to fly closer to Uranus's moons than it had anything else during its time in space thus far, cruising by at a closest distance of 28,260 kilometers, or about 17,500 miles, enough to fit almost 3.5 Great Walls of China in. The cameras on board the spacecraft took and sent back stunning photos of 5 of Uranus's larger moons: Miranda, Oberon, Ariel, Umbriel, and Titania. The exhilarating observations Voyager 2 sent back were thrown into sharp relief by a jolting reminder of the dangers of space travel. On January the 28th, 1986, only 4 days after Voyager 2 made close contact with Uranus, the Space Shuttle Challenger exploded shortly after launching from the same pad that Voyager 2 had departed from. All 7 astronauts aboard Challenger perished in the tragedy.
Did you guys know that there was a plan to put Big Bird as like a Sesame Street, I saw this in another YouTube video, as like a Sesame Street advertise, almost like putting Big Bird in space. Get it? Like a guy with a Big Bird costume. And he almost went on this space shuttle. And imagine if all, obviously it's horrible that these people lost their lives, but imagine all kids across the country saw Big Bird die. Like, how do you explain that? All right, it's obviously
accident. The explosion was a tragic reminder of just how much blood, sweat, and tears go into space exploration. But Voyager 2, billions of kilometers away from this calamity, kept hurtling along on its mission, snapping pictures and sending back data the whole time. When Voyager 2 completed its flyby of Uranus, it performed the largest maneuver it had executed yet and set itself on a course for a flyby of Neptune.
That's so amazing. Ooh, I like that music. How people are so smart. Some humans are so smart. And the fact that the universe is that stable, or the solar system is that stable that you can make such precise...
12 years and 5 days after leaving our terrestrial home, Voyager 2 made its closest contact with its final destination in the solar system, Neptune. This final flyby marked the climax of a 7 billion kilometer or 4.3 billion mile journey through the solar system. And just for reference, that distance is the equivalent of 172,683 trips around the world at the equator. To put that into perspective, if you were to drive around the equator at a speed of 100 kilometers, that's 60 miles per hour, 24 hours a day, non-stop, it would take you 17 days to complete one trip. To complete the equivalent of Voyager 2's journey, it would take you over 8,000 years of non-stop driving. Our intrepid Voyager accomplished that feat in just over 12 years, so I guess they didn't have to stop for bathroom breaks.
Aha.
The Neptune flyby was the closest to Voyager 2's encounters with our solar system's planets. They got as close as 4,800 kilometers, or about 3,000 miles from Neptune's clouds, less than half an Earth away. It became the first man-made object to fly by Neptune, and with all instruments in working condition, it sent back a wealth of data that has shaped our modern perception of the giant blue planet. Voyager 2 discovered 6 new moons and 4 new rings around the planet and introduced us to the coldest known planetary body in the solar system, Neptune's largest moon, Triton, sporting a nitrogen ice volcano. Although methane is the element responsible for giving Neptune its blue color, data sent back reveal that hydrogen is the most abundant atmospheric element on the planet. The images Voyager 2 sent gave scientists more details on the lesser dark spot, the great dark spot, and Scooter, major features in Neptune's
it's like an eyeball.
clouds. Further data reveal dark spot and Scooter, major features in Neptune's clouds. Further data revealed the 1,100 kilometer, 680 mile per hour winds tearing about on the planet, showing scientists that Neptune is a lot more active than they previously thought. After just 12 years, long enough for a child born on the same day as Voyager's launch to experience puberty, Voyager 2 had completed the original plan of the Grand Tour project that it was replacing. Just like human contemporaries, though, the spacecraft too would soon be going through some big changes. Once Voyager 2 left Neptune behind, it charted a course that would take it below and out of the plane of the solar system. Once the craft got 56 million kilometers or 35 million miles away from Neptune...
Wait, that's a good... So aren't, like, I always see the solar system and all these planets are all, like, on a perfect plane, all circling around the sun, but wouldn't it be more like... Actually, I suppose because I think at the beginning they were all kind of circling together, and then, like why wouldn't there be like one orbit like this way and one, you know?
Scientists put its instruments into low power mode to conserve energy for the journey into interstellar space. There exists a bubble of safety that surrounds our solar system. As the sun hurtles through space surrounded by its planets, it emits plasma and ionized material, as well as a magnetic field known as the solar wind. The solar wind extends only so far, stopping at the point where material from other stars and bodies in the universe, often left over from explosions tens of millions of years ago, pushes back. This bubble is known as the Heliosphere. The boundary of this bubble is called the heliopause. It is seen as left over from explosions tens of millions of years ago, pushes back. This bubble is extends only so far, stopping at the point where material from other stars and bodies in the universe, often left over from explosions tens of millions of years ago, pushes back. This bubble is known as the heliosphere. The boundary of this bubble is called the heliopause. It is seen as marking the outer edge of our solar system. In the 1970s, NASA sent out 4 crafts to explore beyond the boundaries of the solar system: Pioneers 10 and 11 and Voyagers 1 and 2. The latter 3 were all sent in the direction of the sun's path through the universe, so out in front of the sun. Pioneer 10 was sent back in the opposite direction of the sun's course. Of these 4 crafts, only 2 have breached the limit of the solar system: Voyager 1 and 2. In 2012, Voyager 1 became the first human-made object to enter interstellar space. On December the 10th, 2018, nearly 41 years and 4 months after its launch from Cape Canaveral, Florida, 21 years after its non-essential instruments were permanently turned off, and 6 years after its twin, Voyager 2 became the second human-made object to leave the solar system. In 2019, Voyager 2 fired up its thrusters to adjust its position. This seemed like a simple maneuver, but it's important for 2 big reasons. First, Voyager 2 hadn't used these thrusters since the craft's encounter with Neptune 30 years prior. Fairly impressive. I mean, when was the last time you picked up a piece of technology 30 years old and it just worked perfectly? Second, these thrusters allow Voyager 2's satellite will remain pointed in Earth's direction, ensuring that we can still receive the data it sends. Since it makes up half of our presence in interstellar space, its data is invaluable to scientists. Although Voyager 2 was only the second craft to cross the boundary between our solar system and the rest of the universe, its crossing was still significant for many reasons. When the first Voyager crossed the heliopause, the measurements it sent back home were incomplete thanks to a defunct plasma temperature detector. However, Voyager 2 still worked, so scientists were able to learn that within 140 million miles of the heliopause, the plasma in the heliosphere slows down, heats up, and becomes denser. As the craft crossed the heliopause, it showed scientists that the temperature of the interstellar plasma is 54,000 degrees Fahrenheit, nearly 30,000 degrees Celsius, which was warmer than scientists had expected. Sounds scolding, but plasma in interstellar space is spread so thin that the average temperature still works out as extremely cold. Since scientists have only breached the interstellar boundary twice, there's still much we don't know about this bubble in which we live. In fact, it's even in doubt if this bubble is indeed shaped like a bubble. More measurements need to be taken to be sure. But there are speculations that the heliopause is spherical, others that it could look like a croissant, and still others that there could be a tail left behind from the solar wind. Now that Voyager 2 has joined its twin in its lonely journey through the enormous expanse of interstellar space, its only job is to send back readings of the plasma and other materials that make up the interstellar medium. In 40,000 years, Voyager 2 will fly by the star Ross 248, and in 296,000 years, it will pass by the brightest star in the sky, Sirius. These flybys will be from distances of 1.7 light-years and 4.3 light-years respectively, enough to fit over 579 heliospheres in at the shortest distance.
Oh, I've heard of this.
These distances is enough to boggle the mind. The time it would take to traverse just 1 light-year at the speed Voyager 2 was traveling when it left the solar system is nearly 20,000 years. That means Voyager 2 will be 34,000 years away from the closest star it will pass in the next several dozen millennia.
34,000 years away from a star?
4,000 years away from the closest star it will pass in the next several dozen millennia. In addition, Voyager 2 will have lost contact with Earth or run out of energy tens of thousands of years before it even gets close to these stars. However, humanity launched these crafts on their lonely missions, hoping that they wouldn't be so lonely after all. On board both Voyager spacecraft is a golden record, a message from humanity. A message to who? Well, to anyone who might bump into these lonely wanderers, since these spacecraft measure not even
Unlikely, I would think.
24 meters from tip to tip at the longest point. They're traveling in a place where trillions of miles is considered a flyby. The odds of any intelligent life form bumping into them are, well, fairly small.
Well, it's a symbolic kind of thing, you know? It's like throwing a message in a bottle in the ocean and hoping that it washes up and someone reads it, except times it by like 1 billion times the size of the ocean.
leaves the
trillion.
intended recipient of our golden record to either be an incredibly lucky spacegoer or a civilization advanced enough to detect something that, if the universe was scaled down to our earthly dimensions, would make a speck of dust look absolutely giant. Nonetheless, advanced enough to detect something that, if the universe was scaled down to our earthly dimensions, would make a speck of dust look absolutely giant. Nonetheless, we humans, hopeful as ever, sent out these golden records with images, pictures, and information about Earth for any intelligent being willing to learn about us and our tiny blue rock. These golden records are actual functioning LPs, like the sort you'd find in the 1970s, playable on a turntable at any disco hall. The record contains various pictures, 16 in total, that show scenes of nature, cities, and humans on Earth, as well as models of our solar system and mathematical equations. There are also various sounds, like greetings in 55 languages, everyday sounds like a train chugging along on train tracks, and sounds from nature, like crickets chirping. There are also 27 tracks of music from artists of all different cultures and generations. The most iconic symbol of the golden record, though, is perhaps the cover in which it's housed. Since the chances of the alien race that found the record having or knowing how to operate a turntable are slim to none, NASA had to figure out a way to explain how to play it. But the chances of the alien race speaking English or any other language from Earth being, again, zero, NASA had to figure out how to communicate these instructions effectively. The crux from which all deciphering of the album hinges on is hydrogen, the most commonly found molecule in the universe. On the cover, scientists put a diagram of hydrogen atoms in the state when they emit radiation.
You really got to think on a strange level to think, what is something we can put on this that any intelligent life form could have a chance of deciphering it. And that's very difficult.
This radiation has a definite wavelength, 0.7 nanoseconds. Scientists figured that any civilization that has mastered space travel and technology enough to find the golden record will be able to decipher this hydrogen riddle. 0.7 nanoseconds is the basic unit of measurement for all the other diagrams on the cover. Using binary code, the cover gives a number of radiation wavelengths, which equates to, when multiplied by the 0.7 nanosecond basic unit, 3.6 seconds. This is the speed at which the record would need to be played in order to make sense of its contents. At this stage, the aliens would easily be able to listen to the songs, sounds, and greetings from Earth. However, to see the pictures, it requires a bit more deciphering. As we mentioned before, these crafts were made during a time when technology was in its infancy compared to today. The golden records are a great example of this. Their storage capacity sits at 69 kilobytes, barely enough to store one picture, and downright measly compared to today's devices that allow us to hold hundreds of gigabytes in the palm of our hands. NASA, known for their out-of-the-box thinking, the box here being the solar system, came up with a way to encode the image data of all 116 pictures. They put the data in the audio waveforms that are played by the LP. If listened to with the naked ear, they sound just like a bunch of buzzes and beeps. However, using the base measurement of 0.7 nanoseconds and executing some NASA-level code breaking, the aliens would presumably be able to decipher the rest of the diagrams on the cover, allowing them to give 2D life to these pictures from Earth.
Pop quiz.
Another symbol
It's an interstellar pop quiz.
on the cover is that of a circle. The circle is there as a way for the aliens to check if they have decoded the image correctly. The first image on the record to decode is a circle. If the aliens see that the first decoded image and the symbol on the cover match, they will know that they're on the right track and not just, running in circles.
Okay, first of all, I'll discuss aliens on another video.
Last, but probably one of the first images you'd notice on the golden records.
Just what are the chances that they're gonna, whenever you see aliens portrayed in movies, it always just, I get it, it's a movie and so you have to make it look sort of human, but you ever notice they always have or so often they have limbs, 4 limbs, and they have 2 eyeballs that just so happen to be on the top of the thing, and it happens to have a head and fingers sometimes. And it's think about the weirdest possible animal on Earth, right? The weirdest possible animal you can think of. A roly-poly bug or something like that, or a squid or an octopus or a plant, right? We would be so much more infinitely similar to those things than we would to a biological thing that evolved on a completely different planet. And so whatever aliens so there are likely aliens somewhere in the universe, right? But what they look like is probably nothing at all what we can possibly imagine. And so that's just one little thing. I hate how aliens are always depicted to look sort of like humans.
Cover is the pulsar map. This map,
Not
which
always,
looks
but
just like a bunch of lines all converging at one point, is a map of Earth's location in the universe. The lines are measuring from Earth to various neutron stars that are giving off pulses of radiation. This triangulation of our location in the universe would give any alien race that discovered our message a map back to Earth and its source, humans.
Yikes. Was that a good idea?
So I really hope you found this video interesting. If you did, please do hit that thumbs up button below. Don't forget to subscribe. Also, if you've got a suggestion for a future Mega Projects video, please do use...
What if they're not nice, and then they come and kill us?
The comments below. And as always,
NASA,
thank you for watching.
Lovely beard. Awesome. Space videos, love this stuff. My name's Connor. If you're new, this is the end of a video, not the beginning. Yeah, awesome video. I really enjoyed that. Not just history, but I almost said astrology, astronomy, physics, everything. I love learning about stuff. So yeah, see you next time. Hope you're doing well. If not, that sucks. You'll be good soon.